Hello everyone, this is again Jasper Chavez speaking, and this time I will talk about the brief history of radiography testing. It is in 1895 when Mr. Wilhelm Conrad Röntgen, a professor at Würzburg University in Germany, observed a fluorescent glow of crystals on a table near his tube, which consisted of bulb with a positive and negative electrodes encapsulated in it. Because of this observation, he concluded that it is a new ray capable of passing through most substances, casting shadows of solid objects.
Hello, Kenneth speaking. About the equipment, radiographic testing is widely used in a variety of industry sectors, including aerospace, power generation, construction, petroleum, chemical and automotive, and for all types of components and parts. The technique is commonly used on welded parts, casting, forgings, composites, and is also used for corrosion mapping and the measurement of wall thickness. Also, radiographic testing of materials is a non-destructive testing method that examines the full volume of a specimens.
Radiography testing is a non-destructive testing method that examines the full volume of a specimen through the use of X-ray or gamma ray to produce a radiograph. Since this test involves radioactivity, some safety rules must be adhered with the guiding principle of ALARA, or as low as reasonably achievable. This includes minimizing the time exposure, maximizing the distance from the source of the radiation, and proper shielding between yourself and the source of radiation.
Good day, I am Enric John Glina and I am here to present the equipment used in conducting radiographic testing, which is a non-destructive testing procedure. First up, we have here the guide tube assembly. So the guide tube connects the gamma ray source system to the collimator. So in short, it acts like a fiber cable in terms of internet connection. So it is the avenue or the passageway of gamma rays that comes from the main device or the main gamma ray unit or the main radiographic testing module onto the collimator, which is the working end of this testing method. Next up, we have the collimators. So the collimators safely direct the radiation beam to just the area of exposure. So as said earlier, collimators are the business end of the radiographic testing process. When the collimator is clamped into the workpiece, it concentrates the beam into just that area in which it is bounded. So this is done in order to test the workpiece for possible deep-seated or deep-rooted impurities, cracks, fractures, or possible failures that occur in the production process of the material or system. Moving on, we now go to the personal protective equipment. First up, we have here the hard hat. Hard hats protect technicians from falling objects or other work-related impacts. It is a requirement when working on job sites, especially those in construction and other job sites that has high-rise buildings, high-rise towers, or other objects that may fall from a high place. Next, we have safety eyewear. Safety eyewear lessens the severity or completely prevents 90% of eye injuries. Proper safety eyewear ensures that the technician is safe from dust, debris, flying shrapnel, or UV light that come from different manufacturing or testing processes. Moving forward, we have the gamma ray source system. So the gamma radiation source system is the main component in this non-destructive testing, which is the radiographic testing. It uses iridium-192 and cobalt-60 in order to emit gamma rays. So its main application or main testing fields involve welds, pressure vessels, high-capacity storage containers, and pipelines. It is used to determine if these said materials or systems have cracks, fractures, or impending failures in a microscopic level. Next, we have the dosimeter film badges. So the dosimeter film badges are commonly used to measure and record radiation exposure due to X-rays, gamma rays, and beta particles. The dosimeter film badge provides a permanent record of radiation dosage. Film badges need to be worn in order to correctly receive an accurate reading of the radiation amount. Correct badge placement is on the body, between the neck and the waist, and on the belt or shirt pocket.
The survey meter detects the presence and intensity of radiation. Survey meters are another safety measure for technicians in the field. There are many types of analog and digital survey meters available for purchase to measure radiation in the field. They all include a detector and a readout display. Analog and digital displays are available. Most survey meters used in industrial radiography use a gas field detector. The exposure time was recorded by a simple stopwatch or timing device during testing. Steel toe boats are worn to protect the feet against accidents and danger. The steel reinforcement in the toe protects the foot from compression caused by falling objects. Occupational safety and health legislation often require the use of such boots in an industrial setting. Safety cones act as a clear marker to others to stay back because there are hazardous radioactive materials being used.
I'm Miles Galileas Maglinte and I will be discussing the purpose of radiographic testing. Radiographic testing is a non-destructive testing method which uses either X-rays or gamma rays to examine the internal structure of manufactured components, identifying any flaws or defects. In radiography testing, the test part is placed between the radiation source and film or detector. Since radioactive testing has the ability to penetrate wide ranges of materials with varying densities to detect internal defects, it can be used in structures or concrete to search for defects without having to destroy it or a part of it.
Hello again, I am John Christopher Munilla and I will now discuss the topic, how to use the radiographic testing equipment. Radiographic testing utilizes ionizing radiation to achieve an image of an object to several different viewing medias. This may be gamma rays or as in this case, X-rays. So first, the examiner marks the weld to be inspected with a measuring tape. This will be visible on the X-ray, thus, he will know how to determine the exact location of possible irregularities. Next, the film is mounted on the object and the X-ray tube is set up carefully. Third one, the examiner leaves the area, closes the lead door, and operates the device remotely. In this way, he avoids coming into contact with the radiation. He adjusts the voltage, current, and duration depending on the investigated material and the wall thickness. Then, he starts the radiation.
Hello, I'm Giancarlo Carillo and I will be discussing the continuation on how to use radiographic testing equipment. In this slide, the X-rays go through the material and generate a radiographic image on the film or imaging plate once processed. Next, the experienced eye of the examiner interprets the image and he can now determine the quality of the inspected object and if it meets the standards. Then, X-rays can also be used to establish the authenticity of paintings. For example, through the centuries, paints contain different quantities of lead by exposing the paint layers to X-rays. It is possible to establish whether a cloth was repainted and the period from which the paint layer is originated. In this case, the radiographic image is recorded on an imaging plate. Lastly, using the computer, a digital radiographic image is read. Art experts can use this to determine the authenticity of the painting.
Good day everyone, this is Roello Julian Jr. presenting safety precautions. First of all, let's define safety precautions. So, safety precautions are the means or measures that must be considered by the key persons involved in an experiment or a task for it to become successful and to be executed well with guidance and safety. Okay, so we have 6 things or safety precautions that anyone who is involved inside the testing site must consider. So the first one is to wear an appropriate clothing. Of course, in performing inside a laboratory or in the testing site, everyone must wear an appropriate attire like PPEs or personal protective equipment. This could include the safety eyewear, hard hat, a dosimeter film badge. Next is to follow the manufacturer's recommendations closely. So I believe that in every commercial devices or products that we use, so, for example in our equipment, the radiographic testing equipment, I believe that in every actions or decisions that the group shall make, it should be guided by the manual or the handbook that is being provided together with the radiographic testing equipment. This is to avoid wrong decisions and unnecessary motions, of course to prevent errors in conducting the test. Third, the exposure to the radiation by the operators should be regularly monitored in accordance with the supplier's instructions. So since safety is our utmost priority in conducting the test, everyone who is exposed during this test must consider their exposure to radiation, because too much exposure will harm the body. So in measuring the radiation exposure, we have this device called the radiation dosimeter. It measures the dose uptake of external ionizing radiation. It is worn by the person being monitored when used as a personal dosimeter and is a record of the radiation dose received. So, in conducting this test we must also consider using this device. Fourth is that the analyst must also ensure that anyone who is not involved in the testing stage is kept away from the testing site. So everyone who is not really assigned or designated in performing the test, they must keep their distance away from the testing site. This is to avoid crowd, disturbance, unnecessary noise, or any factor that could intervene the test. Of course, we're still talking for the safety of everyone, so we must limit the risk of getting harmed by the radiations. Fifth is that a level 2 or 3 analyst is needed to not only prepare the test adequately but skillfully assess anomalies within a structure or weld. This means that the analyst must carefully pay attention to every details that are happening during the testing. This is because of the reason that we are not always sure of the success of the test. We must also consider the chance or the probability that we can maybe commit errors or have anomalies or irregularities while performing the test. Okay, so the last thing that everyone who is involved in the testing must consider is that most importantly, managers and analysts must make certain that personnel are fully trained to commence a radiographic test to minimize the possibility of a serious accident. Of course, in conducting this kind of testing or experiment, we must assess every individual who we are working with if they are capable enough or knowledgeable enough in conducting the test. Since we are prioritizing our safety, of course, this is important to consider because this is not just a simple test. Everyone who is involved in the testing sites are risking their health due to the exposure to radiation. This is why everyone who or the personnel that are involved in this test must have enough knowledge about the radio testing equipment, what is it, how to use it, and all the things that must be considered to prioritize their safety.
Next, we have the preventive maintenance for the radiographic testing equipment. Note, since there is no specific radiographic testing equipment mentioned in the module, the following maintenance is generalized that can be used for any radiographic testing equipment. So step 1 is the tube cleaning. All X-ray machines have a tube which converts the electrical input into X-rays, creating a beam of radiation. General performance and functions verification. General preventive maintenance can be conducted at the user level and begins with using the machine properly as well as routine cleaning. And lastly, performance and safety testing. Routine testing of an X-ray machine helps keep it performing as it should be, as well as identify the small issue before they become catastrophic problem.
That concludes our presentation on the destructive and non-destructive testing procedures. We've discussed the Charpy impact test, which is a destructive testing method, and the radiographic test, which is a non-destructive testing procedure. I hope you've learned a lot, and thank you so much for listening. Again, this is Group 2 from Bicol University, BS Mechanical Engineering 3A.